Learning Kitchen. It's Miss Johnson's Learning Kitchen. Okay, so today, home, sick baby, maybe sick myself, I don't know. Definitely not my most glamorous portrayal, but as always, I'm thinking, how can I teach you? And today, I'm thinking, how can I teach you about conduction? So what is conduction? It's a method of heat transfer. And just like we have all kinds of catchphrases for different forms of energy, with this, we also have a catchphrase. And it's out, don't touch, no touch. Conduction is going to be all about heat transfer through direct contact of molecules. It's the don't touch the pan one, okay? It's the one we're going to remember. So, setting up, here's what we have going. You will notice that I have a pan ready to go. I have a candle going just because I've been cutting onions and it's a little smelly. I could actually talk to you about radiation from this candle, but I'll save that for another day. So first we're going to talk about conduction. Ouch, no touch. So what is conduction? Conduction is the means of heat transfer that occurs when molecules are directly touching each other and thermal energy moves from one molecule to another. Heat moves from one molecule to another straight through objects. Examples of this in everyday life, things like flat ironing or curling your hair. You're conducting heat straight from that metal into your hair and most likely into your ear or your face at some point as well. Other examples of conduction, when you go out on the pavement and you have bare feet and it's very, very hot and you burn your feet, it's because your molecules are directly touching the molecules of the pavement. Anytime there is direct contact, putting steak on a pan, you're going to have conduction going on. So I want to show you a few things about that. I want to show you some examples. So I'm starting out getting ready to make my soup for the week. And I don't know if you can see anything of me other than my hands right now, but that's fine. So starting out, I have my pan ready to go. You'll see my oven, or my stove in this case, is not on. And I have a combination of onions and shallots that I have cut to start my soup out. And I know at this point you're probably going, oh, onions, but I love them, and I also want to use them because they caramelize quickly, meaning that they turn brown and their chemical bonds start to release sugars very quickly, and we can actually see them heat up. All right, back to the pan. First thing, everything's off. I can touch my pan all the way around. I can put my hand in the bottom of the pan. Nothing bad is happening. I can pick up the pan. I can stick the pan to my face. No harm done. It is a perfectly cool pan. Similarly, the eye of my stove, although it's wet, can be touched. No problem. So what's going to happen when I turn it on? Okay, making sure I'm using the right one. And I'm going to go ahead and turn this to high just to kind of demonstrate. So what we should see is that the heat starts coming on very quickly. You will see it getting redder and redder. That is because heat is conducting or moving through all of these molecules. All right, so I'm going to put my pan back on the stove. All right, and as they say, a watched pot never boils, so we'll come back to that in just a second. Okay, so now at this point, I have cut my heat to medium, just for the sake of cooking. And I can feel this pan starting to warm up on the sides. This pan, as you can tell by this iron edge, is made of metal. It's made of iron. Iron has molecules that are very close together, meaning heat goes straight through them, boom, 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 one into another, and it's a very good conductor of heat. When we're talking about conduction, we will also talk about conductors. However, if I go in and I put my hand in, I can already feel the heat coming out, and I start to try to touch the bottom of the pan. It's been heating up for a couple of minutes, and it's extremely hot. If I put my fingers on there now, it's going to be uncomfortable. So, what might happen if, for example, I put something like butter on there? Well, let's find out. Okay, so I have some truffle butter. I don't really know how to explain what truffle butter is to you other than delicious and expensive. And it kind of forms the flavor base of my soup. So if I take a little bit of this truffle butter and put it into my pan now, what I should see is that it pretty much instantly starts melting. Had I done this on a cold pan, that would not be the case. If we look at it even up close, you can see that it's actually sizzling as it melts through. This is because the heat is transferring through conduction from the eye to the pan and melting my butter. And at this point, the sides of my pan are also starting to get hot. So I'm going to go ahead and do the next step, which is adding in some olive oil. All right, so putting in a pretty generous amount of olive oil to make this pot of soup. I can take a look in here and see, you can see that the bubbles are kind of forming. I'm going to keep my heat at about medium. If I'm putting my hand at the side now, I can still touch this part comfortably. Down here, it's really starting to get a little uncomfortable. If I were to stick my hand in the boiling or at least sizzling oil, this would be a good example of why I say the catchphrase for conduction is ouch, don't touch. For example. Okay, 1, 2, 3. Okay, so we can already see my finger is burned. I have burned myself in the name of science. So, Miss Johnson's Learning Kitchen is dangerous. Don't do that at home. So that tells me my oil is now getting very hot. The heat has traveled through the stove eye. Hi, Charlie. Through the pan, even the top of my pan is getting warm, and into this oil. So at this point, my oil is getting very hot. I don't want to get it too hot because it can burst into flames. It's loaded with chemical potential energy. Tons of calories in oil, and we remember calories equal energy. So I'm going to add my onions in, and I have a feeling I'm going to regret not doing this closer up. So let's see if, no, that's not going to work. I'm trying to figure out a good place to put my stand where you'll see what happens when I add my onions. Okay, so I'm going to add my onions in, and I suggest that you just listen. All right, so in the course of just a few short minutes of time, this has heated up by the properties of conduction to the point where that oil is hot enough that it is now conducting heat to my onions. All right, I've taken some time to kind of stir my onions, and I'm going to let them cook at this sort of higher heat, medium-high, in this oil for a little bit. We can see a lot of moisture being released off of them as the heat causes that moisture to escape. And here in a few minutes, I will show you what they look like as they've released more chemical energy as that conductive heat moves through them and causes them to caramelize. Okay, so we are back. Again, a watched pot never boils and watched shallots never caramelize. The conduction has continued. At this point, if I even try to touch this part of ow, it's an ow, don't touch situation. So again, we're thinking don't touch the pot. Don't touch. We have to have direct contact for conduction to occur. You can see that these have browned. That means that conduction has kept going. It has heated these all the way through. And the sugars inside of them are breaking apart, releasing chemical energy and delicious flavors. So, I do want to point out, if I touch this, ow, and it burns me, it's because this pan is now conducting heat to my hand. So, ouch. An important fact to remember with conduction is that things always go from an area of greater heat to an area of less heat. For example, were I to grab this pan, the heat would transfer away from this area that has greater heat into my hands, which have less heat. Conversely, were I to come over and grab this glass of cold water, it will feel cold to me because my hand is conducting heat away from it and into this glass of water. So that's how conduction works. When you pick up something and it feels cold, it's because it's sucking heat out of you. It is conducting heat away from you. When you touch a stove eye and give yourself serious burns and then end up having to go get your hands all wrapped up, well, then you've just been foolish, but also it means that you have had heat conducted into your hands. So it always moves from the area of greater heat to the area of lesser heat. So at this point, I've had my vegetables going in the pot for a little while, and I'm getting ready to go to the next step, which is adding in stock, and you don't need the full recipe. But I do want to ask a question. Is there a way for me to safely grab a heated metal pan without, really injuring myself? Yes, oven mitts. So how do oven mitts work? We talked about things that make for good conductors. Metal being a good conductor because those materials are closely packed together and they're things that allow heat to move through them very quickly. Things like this, we call them insulators. An insulator is something that does not allow heat to move through it easily. With oven mitts, which are made with a lot of air kind of between them, air is a terrible conductor of heat, and they have a lot of other things that prevent conduction from occurring, I can safely pick up this pot and carry it around and show you. I can get the lid off and show you kind of the beautiful beginnings of my soup. It will progress and turn into a lovely meal, several meals hopefully. So we've talked a little bit about insulators. That's important. We've talked a lot about conduction, and we will be back in Miss Johnson's Learning Kitchen to talk more about radiation and convection. Unless you've already watched those videos and then that was just an unnecessary song bit. It's really up to you which order you go. All right, so radiation I think we have covered, and hopefully we will be able to get on with our next bit of learning pretty soon. I'm gonna go put that on some ice. See you later. Bye. Remember, conduction, don't touch it.